Hello everyone, welcome to all in this video lecture series of Database Management System. I am Deepak Aneja, Assistant Professor, ABES Engineering College, Ghaziabad. In the previous video, we have covered the normal forms in which we have already understand the concept of 1NF, 2NF, 3NF and BCNF. Now, in this video, we will do the practice question to find out the highest normal form. So first of all, we will understand this Venn diagram, the relationship between various normal form. So till now, we have understand the concept of 1NF, 2NF, 3NF, and Boyce code normal form BCNF. So BCNF exists inside the Venn diagram, then 3NF, then 2NF, then 1NF. What it means, if if any relation is in BCNF, then by default, that relation or that functional dependency is in 3NF, 2NF, and 1NF. If any relation or functional dependency exists in 3NF, then by default, it will exist in 2NF and 1NF. But it can't be sure that will exist in BCNF. That may or may not exist in BCNF. We need to check that is exist in BCNF or not. If any of the relation or functional dependency exists in 2NF, so it is not sure that will exist in 3NF or BCNF, but by default it will exist in 1NF. Now we will do the practice question to find the highest normal form of a given relation are A, B, C, D, E, F, G, H. These are the attribute of a relation with the functional dependencies are this. Now, step 1 is to find out the candidate key. Now, how to find out the candidate key? From the right hand side, D is already in the right hand side, E attribute, G attribute, H attribute, then G, H, and then E and F. Missing are ABC. Now we will try from ABC. Right? Now find out the attribute closure set of ABC. A, B, C. Then from ABC we can determine DE. From E we can determine GH. And from H we can determine G. And from G we can determine H. So I think A, B, C, D, E, F. Now from A, B, C, D, we can determine E and F. So all the attributes can be determined through ABC. So candidate key is our ABC. Now step 2, find out the prime attribute. So here prime attributes are A, B, and C. Now step 3, we have to find out the non-prime attribute. So non-prime attributes are D, E, F, G, H that are not the part of candidate key are called non-prime attribute. Now we have to find out the highest normal form. For highest normal form, ABC determines DE. Then A determines GH, H determines G, and G determines H. A, B, C, D determine E, F. Now, through the Venn diagram, we have understand if we will start from BCNF, if any of the functional dependency that will exist in BCNF, then we can say that that must be in 3NF, 2NF, or 1NF. Now, we will start from BCNF. So from the previous video, we have already understand BCNF is what? In which the left-hand side should be the candidate key or super key. So ABC is the candidate key. Yes, true. So this functional dependency is in BCNF. Now check for second functional dependency. Is this the candidate key? No. So this is not in BCNF. Now check for this functional dependency. H is the candidate key. No, it is not in BCNF. GH, same. This is not in BCNF. Now check for ABCD. Yes, ABC is our candidate key and ABCD is our super key. So this is true. So we can say that this is in BCNF. Now check for 3NF. Now condition to check for 3NF is left hand side should be the candidate key or super key, or right hand side should be the prime attribute. Now check for this. So no need to check for this functional dependency. Now check for this. Left hand side is the candidate key. No, this is false. Or GH. GH is the prime attribute. No, GH are the non-prime attribute. This is false. So this is not in 3NF. Now check for this. H. H is the candidate key. False. Or G is the prime attribute. No, false. So this is also not in 3NF. Now check for this. G is the candidate key, false, or H is the prime attribute, false. So this is false. So this is not in 3NF. Now check for 2NF. Now the condition for to check in 2NF is left hand side should be the proper subset of candidate key, and right hand side should be the non-prime attribute. This is the condition for partial dependency, or 2NF says there should be no partial dependency exists. Now check for this. Left hand side is the proper subset of candidate key. No, this is false. And GH our non-prime attribute, true. So this false and true means false. So there is no partial dependency exists. So we can say that there is no partial dependency. So we can say that this is in 2NF. Now check for next. Left hand side should be the proper subset, false, and G is the non-prime attribute, true. So there is false, no partial dependency. So we can say that this is in 2NF. Now check for this. This is the proper subset of candidate key, no, false, and H is the non-prime attribute, true. So this output will be false. There is no partial dependency, or we can say that this is in 2NF. So finally, all the functional dependencies are in 2NF. So we can say that the relation, given relation is in 2NF. So I hope you will understand this example. Now let us take one more example. Find the highest normal form of a given relation R A, B, C, D with the functional dependency is this. Now first, step 1. Now we have to find out the candidate key. For candidate key, we have already studied how to find out the candidate key. Now trick is check for the right hand side attributes B, C, D, B, C, D, A, D, A is already there, so no one. Here we have to try from hit and trial method. We'll check for single attribute A, B, C, D. Take the attribute closure of A. From A, we can determine A, and then A, B, C, D. So the candidate key, first candidate key is A. Now check for B. B, you can determine. No, we can't determine. Now check for C, closure set of C. C, we can't determine anything else. So C will be not the part of candidate key. Now check for D. From D, we can determine B, or from BD, we can't determine anything else. Now, here, the failures. Now check for failures for further candidate key. Now the possible combinations are BC, BD, and CD. To take the attribute closer, this BC, from BC we can determine AD. So there is one more candidate key BC, and now check for BD, BD. From D we can determine B, and no more attribute can be determined this. So this is not the candidate key. Now CD, from CD, D to B, and BC to AD. So CD is one more candidate key. So now this is the failure. Now no further combination are there. So these are the finally the candidate key. Now step 2, what are the prime attributes? Prime attributes are A, B, C, and D. And step 3, known prime attribute. There is no known prime attribute. This is null. Now check for highest normal form. The given functional dependencies are A, B, C, D, and BC determine AD, and D determine B. Now check for BCNF. We will start from BCNF. Now left hand side should be the candidate key. So A is the candidate key, true. So this is in BCNF. Now check for BC. BC is the candidate key. Yes, this is true. So this is in BCNF. Now check for this D determines B. D is the candidate key. No, D is not the candidate key. False. So this is not in BCNF. Now check for 3NF. To check only for D determines B. So 3NF says left hand side should be the candidate key. So this is not the candidate key, false, or right hand side should be the prime attribute. So B is the prime attribute, true. The outcome is true. So we can say that this functional dependency is in 3NF. So we can say that the whole relation is in 3NF. Now let us take one more example. Find the highest normal form of a given relation R ABCD with FDs AB determines C, ABD determines C, ABC determine D, and AC determine D. Now step 1, we have to find out the candidate key. Now here C, D, and D. Missing attributes are AB. Now take the closer set of missing attribute AB, AB to AB, AB to C, and AC to D. So the candidate key is AB. Now step 2 is prime attribute. Prime attributes are A and B. Now step 3, known prime attribute. Known prime attributes are C and D. These are known prime attribute. Now check for highest normal form. AB determines C, A, B, D determines C, A, B, C determine D, and AC determine D. Now check for first BCNF. Now BCNF says left hand side should be the candidate key. Yes, true. This is in BCNF. A, B, D. This is the super key. This is the minimal set of candidate key. So this is the super key with the combination of AB. All are the super key. So this is also true, is in BCNF. Now check for this ABC, same case. This is also in BCNF. Now AC. AC is the candidate key. No, false. So this is not in BCNF. Now check for 3NF. 3NF only for, we will check for this functional dependency. For 3NF, left hand side should be the candidate key. This is false, or right hand side should be the prime attribute. This is non-prime attribute. This is also false. So we can say that false equals false, or false is false. So this is not in 3NF. Now check for 2NF. 2NF is the condition for partial dependency. Left hand side should be the proper subset of candidate key. This is the proper subset. No, false, and right hand side should be the non-prime attribute. Yes, this is true. The false and true will be false. So this is, here is no partial dependency. So we can say that the given relation is in 2NF. So the given relation is in 2NF. Now let us take one more example. Step 1, you have to find out the candidate key. Now candidate key C, D, E and B, E. Now the missing attribute is A. Take the attribute closure of A. A, we can't determine anything. Now the pairing with A, AB, AC, AD and AE. Now take the attribute closure of these. AB, AB to C, D, E. So first candidate key is AB. Now take the attribute closure of AC. From AC, we can't determine anything else. So this is not the candidate key. Now AD, from D, we can determine BE. And from AB, we can determine CDE. So this is also the candidate key. Now third is AE. AE, from AE, we can't determine anything else. So this will be not the part of candidate key. So these are the candidate key. Now, step 2, prime attribute. Prime attributes are A, B, D. And step 3 is non-prime attribute. That is C and E are the non-prime attribute. Now check for highest normal form. The given functional dependencies are AB determines CDE and D determine BE. Now first check for PCNF. Left hand side should be the candidate key. Yes, candidate key. So this is in PCNF. Now check for this. Left hand side should be the candidate key. No, false. This is not in BCNF. Now check for third normal form. Left hand side should be the candidate key. No, false, or right hand side should be the prime attribute. B is our prime attribute and E is our non-prime attribute. Prime attribute and non-prime attribute are non-prime attributes. So this is false. So we can say that this is not in 3NF. Now check for 2NF. 2NF says left hand side should be the proper subset of candidate key. D is the proper subset of candidate key. Yes, AD is our candidate key. So D is the proper subset of candidate key. This is true. And right hand side should be the non-prime attribute. B is prime and E is non-prime. Prime and non-prime are the non-prime attribute. This is true. True and true is true. So there is partial dependency exists. So if partial dependency exists, so we can say that this relation is not in 2NF. So by default, we can say that the relation is in 1NF. The given relation is in 1NF. So I hope you will understand the concept of highest normal form. This is very, very important concept as GATE point of view, NET point of view, and university exam point of view. So these are the references. Thanks for watching this video.